Hello, my name is Grace Lunsford, and today I'll be giving a presentation on boiler feedwater systems. To get started, I'd like to talk a little bit about the history of boiler systems. The boiler was first introduced in the late 1700s with the kettle boiler, which was a simple kettle filled with water and hung over a firebox. This was the first time we'd seen steam used to heat a home, and it inspired the development of the first modern-style feedwater system introduced in 1867 by Babcock and Wilcox. This design was a convection boiler utilizing straight tubes inside a brick structure to generate steam. This design was limited by the straight tubing as they couldn't maneuver the steam through the building in the pattern they always wanted to. Thomas Edison used this boiler to power his Pearl Street station in New York City, which was the first public utility. Inspired by this design, in 1891, the Stirling Boiler Company developed the H-type boiler. This was also a brick-setting design, but it was much larger than the B&W boiler. This utilized 3 drums to circulate water and allow steam to flow through the boiler, and had the ability to use bent tubing, so they could maneuver the steam through the building a little bit easier. Driven by a competitive market, the Stirling Boiler Company and B&W decided to merge in 1906. With this merge, the acquisition of the Stirling facility in Ohio allowed B&W to begin production of bent tube boilers. This allowed them to design and produce the best-selling boiler, the H-type Stirling. The H-type Stirling produced up to 50,000 pounds of steam per hour, which was the greatest amount of steam generated by a boiler up to this time. This H-type Stirling boiler is still seen partially in our current boilers today. You can see an example of a modern feedwater system to the left. This is what you would see in an industrial setting, not necessarily your home. Currently, we use an electric combination boiler mostly in housing units. This allows both the space and the water in a home to be heated, ensuring the most efficient system. The heat can be delivered in various ways due to the bent tubing that originated with the Stirling Boiler Company, allowing the heat to be delivered to the baseboards and in-floor systems, along with other areas within the house. Now that we've discussed the history of boiler systems, I think it's important to understand the boiler feedwater quality. When using a low-quality boiler feedwater, you're going to experience a significant increase in operating costs. This is because low-quality feedwater lowers the energy efficiency of the system, making it work harder for your desired output of steam. Additionally, untreated feedwater can result in damage to vital components like your piping, your pumps, and even the boiler itself. One of the big concerns with untreated feedwater is dissolved gases. Carbon dioxide and oxygen are the biggest concern with the dissolved gases, as carbon dioxide can form carbonic acid if allowed to remain in the feedwater, and oxygen by itself causes severe corrosion when not removed. This corrosion is known as pitting, and you can see an example of this to the left. This is a catastrophic failure due to pitting, and ideally you never want your system to reach this point. Another concern is mineral scale. Mineral scale is built up when the water is not treated, and sodium trapped under the scale can lead to pitting. High temperatures are the perfect conditions for a scale to build up, and obviously this is pretty common in a boiler system, so it's something that you need to ensure you're removing prior to operation. Now that we know why we need a feedwater system, I'd like to cover the 4 types of boiler feedwater systems that you're likely to see. First up, you've got an open feedwater system and a closed feedwater system. These are the primary systems, and you'll add a deaerator system or a chemical feed system to these as needed. An open feedwater system cycles raw water continuously to the boiler, making it ideal for small-scale applications. A closed feedwater system recirculates the water from the boiler to a storage tank, reusing this water over and over again and only replacing it when necessary. This makes it ideal for large-scale applications. Added to these systems can be a deaerator system, which removes those dissolved gases from the feedwater like we talked about on the previous slide. And another thing that can be added is a chemical feed system. This uses chemical dosing to remove the mineral scale that also has the potential to result in pitting corrosion. Now I'd like to go a little bit more in depth about each of these system types, starting with an open feedwater system. Like I said before, this cycles raw water continuously to the boiler, meaning a storage tank would not be found in this system. This is best suited for small-scale, low-pressure applications, and it's the best choice when water consumption and water treatment costs are not a concern. Your water treatment costs are going to be pretty high because every time you're feeding water to the boiler, it's raw water, and it requires full-scale treatment every single time. Unlike an open feedwater system, closed feedwater systems recirculate water between the boiler and a separate water storage tank using a condensate return. The water is treated and conditioned before being pumped to the boiler, and again as the condensate is treated before being sent to the storage tank to be recirculated through the system. This is best for use in medium to large scale applications like a power plant or manufacturing facility because it conserves water and minimizes treatment costs while also ensuring water quality. So if you're running a high profit business, you want to ensure that your water quality is good and you're taking good care of your boilers. Now we'll talk about the deaerator systems. There are two types. There's a tray type and a spray type. But first we'll talk about the tray type. As you can see to the left, this is a vertical dome deaeration section on a horizontal vessel. This horizontal vessel will serve as the deaerated boiler feedwater storage tank that can be fed straight to the boiler. In the system, low pressure steam enters from the bottom of that vertical section, while boiler feedwater enters from the front. They both flow through these perforated trays in opposite directions, allowing the steam to strip the dissolved gases from the water, and then these steam and dissolved gases vent through the air vent at the top. A pack bed may be used in place of trays as needed for the system, but it's far less common than these perforated trays. Next, we have a spray type deaerator system. As you can see to the left here, it's a horizontal vessel with preheating section and a deaerated section. These two sections are separated by a baffle, which if you're unfamiliar with what a baffle is, that is just a separator used in a vessel or heat exchanger to direct the flow of a fluid. At the bottom, you'll see a steam sparger. That is a sprinkler-like system for introducing gas into a liquid. It's very similar to the fire protection systems that you see in your house or in any building. It's just modified to introduce a gas into a liquid. In the system, the feedwater is sprayed into the preheating system from the top, while the sparger introduces steam at the bottom of the tank. It works the same way as the tray type, where the steam flows through the boiler water, removing or stripping those gases and then venting through the air vent in the top. The last system we'll talk about is a chemical feedwater system. This is typically required after the deaerator tank to remove the last 3 to 10% of impurities from boiler feedwater. Most commonly, this takes the form of oxygen scavengers, which are introduced to dissolve the remaining oxygen from the feedwater. Most commonly used are hydrazines and sodium sulfite. You can see the chemical equations below showing how the introduction of these chemicals results in the bonding of that oxygen and removes the harmful dissolved gas from the system. To determine your required chemical dose, you take your oxygen content times your standard chemical dose rate, which differs based on the chemical being used, and then you add a chemical reserve. This chemical reserve ensures that you're never too short on this chemical and that all of the dissolved oxygen is going to be removed. Now that we've talked about each of our feedwater systems, I'm going to walk you through a boiler system as a whole so you can understand how these components tie together. First, we start all the way at the beginning with the source where the feedwater enters. From there, it goes through a clarifier and a filter. The clarifier removes solid particulates and suspended solids within the feedwater. And from there, it moves into the filter, which removes particles at a micron level, which is much smaller. Next, you can see the brine tank, which removes hard water and minerals like calcium and magnesium. And that's used in tandem with a zeolite softener, which removes hardness contributing cations, but leaves the sodium in the water. This is only suitable for low pressure boilers, so you would not see a zeolite softener in a high pressure boiler. Next, you can see the storage tank that stores the feedwater before it's sent into the deaerator tank. And again, that deaerator just removes the dissolved gases from the feedwater. Next comes the boiler internal treatment, which just removes contaminants such as iron and salt from inside the boiler. Included in the deaerator tank, you can see those oxygen scavengers. Those are those substances introduced to remove the remaining oxygen from the feedwater. Before the boiler, you'll see an economizer. This is a heat exchanger used to preheat the feedwater going into the boiler. This is because if you introduce warmer water, it takes less energy to create the steam that you want from the boiler rather than if you introduce a cold water to the boiler. The boiler heats the feedwater to generate steam, and exchangers in these systems are most commonly shell and tube, but this can differ from system to system. Lastly, you'll see the condensate treatment and the condensate receiver. The condensate treatment is used to remove traces of contamination from the condensate, like I addressed earlier in the presentation. And the condensate receiver is the tank that's used to store and distribute the collected condensate to recirculate it back into the system. Next, we'll talk about the TS diagram. I won't spend a lot of time on it, but it's important that you understand that you're looking at a closed feedwater system with a condensate return. What you're seeing is that the pump drives the steam pressure and circulates the water, which again is being recirculated between the boiler and a separate storage tank. The boiler functions only as a temperature modifier, and under the vapor dome, the feedwater is a liquid and a vapor before going into the boiler where it adds heat to make it steam. The pressure in the boiler is not altered at all, and the sole driver of steam pressure is that pump. So key takeaways from this presentation are that the boiler feedwater quality is critical for corrosion prevention. Poor quality results in pitting and scale buildup, as well as low energy efficiency of the boiler. There's 4 types of boiler feedwater systems that you can see: an open system, a closed system, chemical feed system, and a deaerator system. These are used in different ways to get the best fit for what you need. So you may see a open system with a chemical feed system, and that's it. Or you'll see a closed system with both a chemical feed and a deaerator system. It really comes down to what the boiler is being used for. And lastly, the feed pump drives pressure changes while the boiler serves as a temperature modifier. It's also important to note that only subcooled liquid can be pumped, or cavitation can occur within the system. That's all I have for the presentation. Thank you so much for your time. If anybody has any questions, please feel free to ask. If not, we can get right into the quiz.